AP Chemistry, Unit 5.5, Collision Model. Particles must collide to react, and the greater the number of the collisions per second, the greater the reaction rate will be. Particles must also have sufficient activation energy, which is going to be the minimum energy in order to break apart bonds. And particles must be in the correct orientation in order to react as well. So for activation energy, particles with a greater energy than the activation energy have enough to react, while particles with lower energy than the activation energy do not have enough energy to react. If we were to look at a diagram where we can see the overall portion of our particles on our y-axis versus the energy that those particles have on our x-axis, and we have our energy of activation line here, we can see that any molecules that have energy less than the energy of activation do not have enough energy in order to react, but the particles that have energy higher than that of the energy of activation do have enough energy to react. One way to increase the number of collisions is to heat up the sample. If we heat up the sample, then the particles are going to be moving faster, and the overall energy of the particles are going to increase. And when the temperatures increase, the distribution curve peak is going to shift to the right, so we have more overall energy, and it will flatten as well. So what this could potentially look like is this, where we have our curve here. We have our initial temperature and then our increased temperature, and our peak shifted to the right, but our overall peak also flattened out. And then we can see that we have a greater number of overall molecules that have enough energy in order to react. And if we increase the number of molecules with enough energy to overcome the activation energy, then more reactions will occur, and we will be able to increase our rate of reaction. And of course, this again is if T2, this purple line, is greater than that of T1, if I increase the heat of the overall sample.